Hi kids, Mr. Engen here, moving on with our next lesson in math. It's going to be theoretical probability. So you're going to want to take notes like normal and get out a piece of paper and feel free to pause the video at any time. I can calculate the probability of an event using fractions, decimals, and percents. So what probability refers to is the likelihood of something happening. And this part here is going to be really important. What we first do with probability is we express it as a fraction, okay? And what goes on the bottom is the total number of possible outcomes. So all the things that can happen goes on the bottom all the time. And then whatever the number of ways the event or the thing can happen, like what we're looking for, that's the number that goes on the top, okay? It's going to seem kind of fast because I have to keep this video to 15 minutes. Okay, so we have a dice, okay, or really a die. One dice is a die. It says, what is the theoretical probability of rolling a 2 on a standard 6-sided die? So, again, the total number of possible outcomes is the number that goes on the bottom. So if I roll a die, there's 6 possible sides, right? 1, 2, 3, 4, 5, 6. So the probability of getting a 2, okay, well, that's the number that will go on top. So 6 total possible outcomes goes on the bottom, and because there's only 1, 2, right, there's one side that has a 2, 1 goes on top. So the probability of getting a 2 is 1/6. Now we have to be able to convert these to percents and decimals, and we had a past unit on that. So you could use your calculator or long division, right, to convert this also to a decimal, which would be 0.1666, going to go on and then be 7, okay? And that, of course, as a percent, we would times that by 100, and it would be 16. We could round this up, right, to 16.7%. So the probability to roll a die and get a 6 is 1/6, or 16.7%, or 0.16 repeating. Okay, now here you just see a capital P and then the word red. And what this means is it's asking us, the capital P means what's the probability. So it's asking us the probability to land on red on this spinner, okay? So again, my bottom number is always going to be how many total outcomes are there. So I have to count how many spots there are in the spinner. There's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 total possibilities. That's my denominator, okay? And the probability of getting a red, well, how many reds are there? There's 1. So it's 1/8, okay? And again, you will be expected to also be able to represent this as a decimal, right? So we can go 1 divided by 8, and as a decimal, it would be 0.125, right? Or 125 thousandths, or 12.5%. So all these represent the same thing. They're just different ways to express it. Okay, so we're going to use this spinner here. Find the theoretical probability. Don't let the word theoretical hang you up too much. Just, you know, what is the probability of landing on a 5 here? So, again, we're going to look. How many total spots do we have? 1, 2, 3, 4, 5, 6. So 6 is my denominator because there's 6 total outcomes. And how many have 5? Well, you gotta look carefully. It's not just 1, there's 2. So it would be 2/6. And if you are wondering if we reduce, we absolutely do. So this would actually be 1/3, and hopefully that looks familiar to you, right? 1/3 would be as a decimal, 0.33 repeating, and as a percent, 33.3 repeating percent. And we'll have to be able to do all of those. Okay? It says here, how is the probability of landing on a 5 impacted? if one additional 5 section is replace the 1. Okay, if we read that carefully, that means we have to get rid of the 1 and put another 5 there. So now what happens? What is the probability to get a 5 now? Well, now instead of having 2, right? Instead of having 2, we have 3 ways to get a 5. So we still have 6 slots, but now it's 3 out of 6. And of course that would be reduced to 1/2, and that would be 50% or 5/10. Okay. Okay, now we're going to go over some examples of things that are certain, equally likely, or impossible to happen. Okay, so here you see the probability of having a die or land on, it says an A, or the letter A. Well, I'm talking about a standard die that has 1, 2, 3, 4, 5, 6. There are no letters on that, right? So if I roll one of those, it's never going to have an A, or the letter A. So the probability of that happening, we could represent that or write it as 0/6, or we could express it as 0 or 0%. Those all mean the same thing, right? It's not going to happen, right? That would be something that's impossible. An example of something that is certain, in math the word certain means it's going to happen for sure, all right? That would be, so if I roll a die, probability of having a die land on 1, 2, 3, 4, 5, or 6. So if it lands on any of those numbers, well, that's going to happen every single time, right? Those include all the sides of a die. So the probability of that happening would be 100%. Okay? Or actually saying a probability of 1, right? That's the same as 100% as well. Okay? An example of something happening that's equally likely, so like 50-50, right, would be flipping a coin. If we flip a coin, the probability of it landing on heads is 50%, the probability of it landing on tails. So the probability would be 50% or 1/2. Okay, anything equally likely is expected to happen 50% of the time for both possible outcomes. Okay, all right, now we're going to go to this problem. A bag has 12 green cubes, 10 brown cubes, 6 blue cubes, 22 yellow cubes. We have to represent these things as fractions, decimals, and percents. All right, first question, what is the probability of picking a yellow cube? Okay, so here again is that notation with capital P, probability of yellow. Well, I need to know how many total cubes there are in this bag, right? So if I add all these things up, I get 50 cubes, right? The probability of getting a yellow one, well, is 22. And 22 over 50 is going to reduce to 11/25. And that, as a decimal, would be, hopefully you recognize this, as being a factor of 100 makes things easy. 44 hundredths, and then 44%. Okay, so feel free to pause the video now and try the next one. What is the probability of not picking a green cube from the bag? So we want anything that's not green. And then the next one, and if we do that one, so pause it and do it, that one will end up being, out of 50, how many are not green? Well, we don't count the green ones, so we would have 38. Out of 50, that would be 76 hundredths or 76%. Okay? Try the next one. I have to scroll down quick. So the probability of picking a green or a yellow, try that as well. Green and yellow, that would be 12, 22. So that would be 34 out of 50. That would be 68 hundredths, 68%. All right. Try these next two problems on your own. Pause the video. What's the probability of getting a 6 when rolling the fair number cube? Which of these events has a probability of 0? Answer for this is B. Answer for this is A. You're never going to draw a green marble from a bag that only has red marbles. Try the next two, please. Nick has a bag of fruit that contains 8 apples, 4 oranges, 3 pears, which has a probability of being picked at 2/10. Jimmy has a sock drawer with 12 white socks, 8 black socks, 8 green socks, 2 red socks. If he reaches in and randomly takes out 1 sock, what is the probability it will be red? For this one, the answer is A, a pair, and that's because it would be 3 out of 15, and that would reduce to 1/5. And if we convert that to a decimal, it would be 2/10. And then for this one, for the sock one, well, probability of getting a red sock would be 2 out of 30. If we look closely, we recognize there is no 2 over 30, but we have to reduce it 1/15. 1/15. The answer is A. Oops. Last two right here, you want to pause it and try these, please? Class contains 16 boys, 14 girls. The teacher calls on a student at random to recite what is the probability this first student called upon will be a boy. The next one says 9 balls are numbered 1 through 9. What is the probability of picking a ball with an even number on it? Just pause it and try these. You will answer them on the video as well. Answer to this one is 16 out of 30, which isn't here, but again reduces to 8 over 15. If you got that, you're doing really good. The answer is D as in dog. And then here, 9 balls are numbered, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Probability of getting an even one? Well, we have 2, 4, 6, 8, right? There's 9 possibilities, and there's 1, 2, 3, 4 that are even, and then they're looking for a percent. It'll come out to be B. That's it. So hopefully things are going well. If you have questions, feel free to shoot me a message, and I hope everyone is doing well. I'll be back soon.